Okay, this is a two-dimensional motion problem, so let's draw a diagram so we can understand what's going on. So we've got a cliff that is 55 meters tall, or building, and the rock is thrown off of the cliff with an initial speed, v0, of 33 meters per second, directed 22 degrees below the horizontal. Now the rock is going to perhaps encounter a wall. The wall is 45 meters away, and the wall is 12 meters high. So let's see, that means that the rock has, 43 meters of downward displacement that it can travel. And so what we want to know is, is this rock going to follow a trajectory like this, where it goes over the wall, or is it going to follow a trajectory like this, where it falls short of the wall? All right. Our v0, we've got an x component and a y component. We're going to assume for this problem our sign conventions are going to be that to the right is positive and down is positive. That's the general direction of motion. So I think that'll be easier. And with this sign convention, I can split my initial velocity into components. Okay, because I'm going to need to do x and y components for this. So the initial x velocity is 33 cosine 22 degrees. The initial y velocity is 33 sine 22 degrees. Both of these are positive according to my sign conventions. My acceleration vector, it's in free fall, so it points downward, so it has an x component of 0 and a y component of 9.8 meters per second squared. All right, so what I need to do now is I need to determine my x and y components, all my different variables in x and y. I need to figure out what my assumptions are, what is known and what is unknown. So if you haven't already done this, then you should pause the video and see how far you can get in this problem before you come back and look at my solution. Now my strategy for this problem is going to be to find delta y when delta x is equal to 45 meters. Right? I want to know how far it has traveled in the y direction, and I'm going to compare that to 43. Right? And so if delta y is greater than 43, then it falls short. And if delta y is less than 43, then it passes over the wall. So delta y is what I'm going to try to find. So in the x direction, the x displacement is 45, the x velocity, the initial x velocity is 30.60. That's 33 cosine 22 from up here. The x displacement, or I'm sorry, the final x velocity is 30.60 also, because the acceleration is 0 and the time of flight is unknown. In the y direction, the y initial velocity is 33 sine 22, which is 12.36. Y velocity, final y velocity is unknown. The y acceleration is 9.8. Okay, and we're working in MKS units. Doesn't hurt to remind ourselves of that once in a while. So, I only know 2 of my 5 y variables. So I'm going to need to solve the x component first. So, in the x direction, I've got delta x is equal to v0 xt plus 1/2 axt squared. So 45 is equal to 30.60 t, which results in a time of 1.47 seconds. So I'm going to plug that into my y component. Okay, so in the y direction, I need to find delta y. So I'll use the equation that doesn't have final velocity in it. That's delta y is equal to V naught YT plus 1/2 AYT squared. So that's 12.36 times 1.47 plus 1/2 times 9.8 times 1.47 squared. That calculates out to be 28.76 meters, right? So delta Y is 28.76, which is less than 43 meters. Therefore, the rock passes over the wall, and we're done.